is from the Dayton Regional STEM School, and did you work directly with Dr. Williams at Tech Edge? Okay, and so we're going to kind of switch focus from a little more generic view to a more specific project. So he's going to talk to us about detecting vehicles with anomalous, drunk, or distracted drivers using traffic camera feeds.
Okay. Yes. So hi, my name is Vidur and I'm an 11th grader at the Dayton Regional STEM School. And this summer, and I'm still actively working there, I was an intern at the Discovery Lab. And the Discovery Lab is located at Tech Edge. You may have heard of it. It's affiliated, it is part of AFRL, but it is technically located off of base. So students like me, we don't need actual security clearance and things like that. And so we are allowed to work there. And I worked under Dr. Rob Williams, who is the research director. And the project I worked on was traffic camera distracted driver detection, TCDQ. And the basic idea of this is to use traffic camera feeds to detect drivers who are either drunk, distracted, whether it's phone or other people in the car, or otherwise exhibiting otherwise anomalous behavior. So today I'll just go over the motivation and the actual goal of this project. Then I'll go over briefly the actual language and environment used, and then the actual process of detecting drivers using image processing and machine learning algorithms. And then I'll go over how this is actually going to be implemented and my future plans and the business proposition for this. So let's start with the motivation. So I initially wanted to do a summer internship in two main fields, sensor data processing and machine learning, because these are arguably some of the most important fields in computer science today. So then I moved on to looking at problems that are prevalent everywhere and that can be quite comparatively easily solved. And the number one thing that came up is drunk or distracting driver. Now there's a reason currently there are no systems in place that are not based on humans that are used to detect drunk drivers. Except for a human, it is pretty easy to tell. They're swerving in and out of lanes, they're going either very slow, they're making very huge corrections, so it's quite easy for humans to detect. So that's why I was interested in seeing, well, is it feasible to have a piece of software detect it? So in terms of the prevalence of the problem, every day, at all times, there's around 660,000 distracted drivers on the road, and that is a number from the CDC. And 421,000 people were injured, and this is excluding drunk driving. This is just texting, things like this. And drunk driving is an even bigger problem. There's 10.3 million drunk drivers every year. That's estimated by MAD. And the only current way to prevent this is just PSAs, and there is no active monitoring going on. So the actual goal of this project was to receive real-time traffic camera data. And this is done through three main sources: surveillance cameras, which a lot of private institutions have; red light cameras, which are just monitoring intersections, and their main purpose is just catch the license plate; and then traffic cameras. And traffic cameras, each three of these have different properties. Traffic cameras are used if they're publicly available and they're all across our highway systems. But the main catch behind traffic cameras is that they're blurry enough that you can't tell the license plate, so there's not much of a privacy issue. And the main reason is just for actually monitoring traffic, whether it's traffic flow, amount of cars, things like that. Surveillance cameras and red light cameras are both very, you can get high quality images, good frames per second. But unfortunately, a lot of times it's either not publicly accessible, or it's not publicly accessible for most places. So the goal was to take whatever data can be found, and then use numerical engines such as Octave or MATLAB, and Octave is a free version of MATLAB. And to output, the eventual goal is to have a police officer, if you've seen laptops in their cars, output small 10-second clips showing a video of a distracted driver. And then the police officer can then make the final call as to whether the person is actually distracted, and further law enforcement can take further action from there. So just more about Octave. So this is a numerical computational language, and one of the best things about Octave is it's completely free, and because there's a pretty big open source community out there, there's a lot of things, especially image processing. There are already a lot of pre-made algorithms already out there. And MATLAB has a GUI, graphical user interface, but Octave runs in command line. and it runs on Linux, or there's ways to get it to run on Windows. The problem with Octave, and obviously a problem with any type of freeware, is a lot of MATLAB functions are not implemented and have to be written from scratch. And just going back there are also lots of other languages. There's something called OpenCV. It's a set of image processing libraries created by Intel. Now, things like that, those algorithms are far better than anything that's out there for Octave. But I made the decision to use Octave because the Octave gives me the ability to write at a much lower level, and so I have much more control over the actual algorithm. And the eventual goal is to eventually push this out to OpenCV or a much more refined language. So the first thing you have to do is you have to blur the traffic camera data. So let's talk about what an image actually is. At its most basic level, an image is actually a stack of matrices or tables of numbers. So there's RGB. So you have a stack of numbers from 0 to 256 that show how much red is in the picture, how much green, and how much blue. So what you can do is you can average these two and create one matrix. And this one matrix has values on a grayscale. So that's how you make something black and white. Then you can use the Gaussian or the normal equation to remove all the outliers. And this is especially useful because if you're imagining a traffic camera, you are out in the sun, there's lighting issues, there's glare, things like that. So using the Gaussian equation and the Gaussian blur helps reduce noise as well as things like lens flare and other anomalies like that. Then there's the traditional blur, which is what we think of. It's just take the numbers